Hello everybody to this update on IKT's research activities. My name is Bert Bosseler. I am Scientific Director of IKT, the Institute for Underground Infrastructure in Europe. Our headquarters is located in Germany and we have a branch in the Netherlands. First, I'd like to welcome all participants from Europe in the afternoon, from North and South America in the morning, and even from India and Singapore, where it is late at night now. Welcome everybody to this 45 minutes update. I'm going to switch off my camera now so we all have a better look at the presentation. So what is the goal of today's webinar? Well, of course, we want to give you an overview about our research activities. But moreover, we want to initiate a dialogue with you. So if you think that there is an option for cooperation, joint activities, or an exchange of experience, please contact us. Please send us an email with your feedback. Then we are going to follow up to your email, for example, by an individual meeting with you on a specific subject. And us, that is me, Bert Bosseler, and both of my colleagues who are with us today. In the middle you can see Zissis Kamarianakis. He is responsible for all our international activities. Next to him, it is Thomas Bruggermann. He is responsible for project development at IKT. So he is the one to push all the good ideas towards projects and funding. So let's take a look at our agenda now. First, I'd like to start with some technical details for the webinar and a short overview about IKT. Then we are looking at our IKT projects in 4 parts. First, with regard to sewer system analysis and engineering. Then, looking at trenchless and open cut methods, and eventually taking a look at operational issues. We are going to close the webinar by some general remarks and how you can join us in our projects, and by a final Q&A session for your questions. So, let's go ahead. Some technical details in this webinar. If you want to contribute, please use the chat function on your control panel. All the time you can send a message to me or to Zissis and Thomas. We will collect all of these messages and discuss them in the final Q&A session, or get back to it later by email. Your microphones will be muted during the presentation. The main reason is that we want to avoid background noise or feedback loops. We are going to open all microphone channels during the Q&A session. Then, if you do not use the microphone, please mute it yourself. There are also 6 camera channels. You can use them too during the Q&A session. You can also share your camera during the presentation to call attention. For example, if you want to interrupt the presentation and contribute something of specific importance. Today's update is produced at IKT's headquarters in Gelsenkirchen, Germany, which you can see on this slide. We also have a branch in the Netherlands in Arnhem, and one of our Dutch staff members, Bas Luijmers, has also joined us today in this webinar. IKT is a neutral, independent and non-profit institute. However, in German, we do not call it non-profit but gemeinnützig, that is something like serving the public good, creating public benefit. I think that sounds much more positive. Our shareholders are 2 associations. One of network operators like municipalities, utilities and water associations, and one of the industry, for example companies who are providing services for these network operators, like construction companies, consultancies or industrial organizations. Both shareholders do not expect any profit and they have stipulated in their statutes that they won't influence our work. And that's the very reason why we are neutral and independent in all our activities and actions. My office is right here, and that's where I'm sitting now and presenting to you. In the background, just next to our offices and the conference rooms, there's a large technical building which comprises our testing facilities. In our indoor and outdoor facilities, we can test underground systems on a 1-to-1 scale. That means pipe soil systems, vehicle loads, groundwater issues, and even subsurface construction processes like pipe jacking. All these can be simulated on a 1-to-1 scale in a very realistic and practical way. And we really need and use these facilities. In research projects, we look at the system behavior and life cycles. Understanding the system means to identify the relevant quality factors and influences. Once we know these quality factors, we can develop test programs for approvals and acceptance tests. And sometimes we even start comparative product tests for a better quality assessment of all relevant products on the market. In education, our facilities help to visualize technical processes and technical requirements, and we can also demonstrate innovative developments. Moreover, a very important part of our work is networking. That means we organize networks of municipalities and utilities to exchange experience and strategies, or even to develop joint research and testing projects. And about these projects, I want to talk now. And the first area is sewer system analysis and engineering. And a very important issue there is I&I, infiltration and inflow, to our sewer systems. And the question how we can reduce I&I, and also what happens if we succeed. The reason why we want to reduce infiltration and inflow is quite simple. Our systems are not designed for large amounts of extra water. Too much of this water leads to the collapse of sewer hydraulics and wastewater and stormwater treatment. Even if it does not yet is a collapse, it is certainly an increase in costs for pumping and treatment. However, stopping infiltration can also lead to other problems. Once the sewers are sealed, the groundwater level may rise again. In consequence, buildings, vegetation and infrastructure can be affected by humidity or even outer water pressure. We took a deeper look in this issue in a research project that was funded by Germany's Environmental Protection Agency, the so-called UBA, Umweltbundesamt, a kind of EPA Germany. The project was led and organized by IKT, and during the project all issues were addressed by different scientists in the work packages. We took a look at the general situation of infiltration in sewers, we checked laws and regulations, and we analyzed the current knowledge about the effect of large amounts of infiltrating water on treatment plants and stormwater overflow. We as IKT also took a very close look at the effect of sewer rehabilitation on the groundwater level and the consequences of a rising groundwater level. As a result, a final report has been published. The complete report is in German, however, an English summary is included. It's about 20 pages long. 3 of the main conclusions are summarized on this slide. First, infiltration is indeed a severe problem for hydraulic capacity and wastewater treatment. We have to address the problem and we have to find solutions. Second, we have to be careful. Stopping infiltration may lead to other groundwater-induced problems. Problems for vegetation and building structures. Sealing the current system means that we have to find an alternative for groundwater runoff and groundwater management. So, stopping infiltration starts with the design of new drainage systems for groundwater runoff. And finally, maybe the most important one, there is a need to define by law, certain responsibilities for groundwater management. Wastewater and rainwater management, all this is often defined as municipal duties. However, for groundwater management, there is a lack of responsibility. Only for specific areas, for example for coal mining areas, someone feels responsible. Usually, nobody feels responsible. So new legislation is needed, I could say at least in Germany. Moreover, reducing I&I successfully means we have to look at all components of the systems. In our sewer systems, a lot of different components are used, often changing dimensions and materials in manifold ways. The quality of these components and how to check their sealing quality against infiltration, that was the topic of another research project. The report has just been published, like all our research reports, however in the German language. In these examples on the slide, we can see in the upper line plastic pipes connected to clay or concrete, be it at joints, at laterals or at manholes. Below we can see glass fiber liners sticking to concrete or clay pipes, injection methods connecting soil, pipes and rubber sealings, or even a simple liner ending in a manhole. And we all know the risks of this particular example. Infiltration can still flow all through the annular gap between liner and hosepipe to enter the system and the manhole again. So, what were the main conclusions of the project? Well, it might be obvious, but for testing it is still new. External and internal water pressure are definitely two very different things. Internal pressure tests are common for acceptance of major construction works. However, even the systems might be firm and stable against internal pressure, external water pressure might still overcome the sealing effect. That's quite obvious, for example, for a short liner. By inner pressure, the short liner will be pressed against the hosepipe, while by outer pressure, it will be detached from the hosepipe. And such effects might also be true for other, less obvious sealing systems. Because of these effects, in our approvals and comparative tests, we stress the need for outer water pressure tests and for real one-to-one scale groundwater simulation. And there are further risks from a rising groundwater level. In one-to-one scale test, we check the performance of house connection liners against a rising groundwater level. On this picture, you can see 6 house connection lines in our large testing facility. They are 15 meters long and affected by various simulated damages like holes and cracks. The whole box is 6 meters deep, so we were able to install 6 such layers of connection lines, one layer of 6 lines above the other. In the end, the box was full of soil and house connection lines, 36 lines in total. Then the connection lines were rehabilitated by using different liner systems. And during the test, we monitored what we thought would be the major risks. And what kind of failure did we expect? Well, first we took a look at leakages. For example, water tightness tests after installation. Then there is a risk of flow in the annular gap between liner and hosepipe, especially if the liner does not stick to the surface of the old pipe. And finally, liners are prone to buckling. That means they can lose their structural stability under outer water pressure. Well, to make a long story short, nothing of this has happened in the test. However, something else occurred. After the rise of the groundwater level, we observed cracks at bands and joints of most of the products. In consequence, water infiltrated again. The reason was not so simple to identify. We had to dig up the lines to understand. On this picture, you can see the joints of the hosepipe. Apparently, in some cases, the resin has entered the joint and even filled pores in the ground. Another effect was that at some joints, the adhesion and bonding effect between liner and hosepipes were excellent. You can see it at the green liner. The problem is that if the groundwater level rises, we get buoyancy, uplift effects in the soil and the pipe system. And if the liner can't slide along the pipe surface, then even minor movements of the joint can lead to large strains in the liner. The liner bridges the gap at the joint, but it is just a small part of the liner that stretches under the expansion of the gap. So in consequence, the strained liner will crack and groundwater gets into the system again. You could say the liner becomes a victim of its own sealing success, as the groundwater is rising and uplift effects threaten to damage the liner again. We checked this effect in various measurements and finite element calculations. The sensitive areas are especially at the entrance to the manhole and at bands, but also at variations in the depth of the sewer line, which is a particular issue for house connection lines. One solution to the problem could be to reduce the bonding effect between liner and hosepipe to such a degree that the liner will slide before cracking. On this slide, you can see a typical test for liners and gas pipes. For these pipes, movements of the very long old pipeline may cause very large crack spans that can definitely only be bridged by a sliding liner. So after this analysis of the behavior of the sewer system as a whole, with regard to infiltration, we want to take a look now at some further technical projects. Let's start with trenchless technology and pressure pipes. On this slide, you can see our test run at IKT for pressure pipe inspection and pressure tests. In this test, we find bands, curves, upper zones, and various installations, for example, to simulate leakages. On the small graph, we can see the different elements of the test run. With regard to wastewater pressure lines, IKT is active in many different ways. We have compared cleaning and inspection techniques, we have developed a strategy for risk assessment, and we have analyzed the market of inspection and rehabilitation techniques. Some major conclusions are summarized on this slide. For cleaning, various methods are available based on, for example, pigs or compressed air. Inspection devices, however, are rare. For metal pipes, we can use devices known from pipeline engineering. However, for plastics or concrete, we still need visual inspections, or we have to analyze acoustic or flow measurement data to identify leakages. For example, data from the pumping stations. A major problem for sewer pressure pipes is in many cases a lack of accessibility to the pipeline and lacking valves for de-airing prior to inspection. At the moment, we are preparing several new activities and projects. One is that we are developing a strategy for the risk analysis of pressure pipelines in sewer systems. Moreover, a major comparative product test will start in 2017, a test of lining methods for pressure sewer pipes. In recent years, a focus area of IKT's research has been manhole rehabilitation. Since the beginning of IKT, we have investigated all kinds of loading and rehabilitation scenarios, starting from the manhole cover and frame, looking at the cone, the shaft, and the bottom of the manholes. Of course, the quality of rehabilitation and repair was of major interest to us and our members. On this slide, we can have a look at one of our research projects. In our large testing stand, 6-meter deep manholes had been rehabilitated by using lining and coating techniques. All techniques were tested on a rising groundwater level, that is, outer water pressure. Here, you can see a collection of pictures after installation. This project, like every major project at IKT, was accompanied by a steering committee of municipalities, utilities and water associations. They met to discuss the results and to take a deeper look into the performance of the products. And it's not just looking from above like on this picture. The members of the steering committee also check the results in detail. In this project, for example, in one day, they were able to inspect and evaluate about 20 different products under the same loading conditions. If you want to do this on site in your network, this would take weeks. All in all, the quality of the lining and coating systems was quite okay, of course, with some exceptions. The interesting question, however, was, what is the major quality factor? And what is the major risk for manhole rehabilitation? In our test, we have seen it is the preparation of the surface, the preparation of the substrate. The old manhole material has to be prepared in a very diligent way, for example, by high-pressure cleaning. A coating or lining can only stick to the surface if the surface is clean and rough. An old rotten material has to be removed completely before rehabilitation. However, as you can see from this picture, a manual cleaning device might look good on a picture of our steering committee, but in practice, in a narrow manhole, such devices cannot be applied in a proper and safe way. So other automatic techniques are necessary. Here we can see the application of an automatic system using a flow of 50 liters per minute and applying a pressure of about 900 bars. Don't be surprised, but you really need such an extreme pressure to prepare the surface properly. Here we can see the surface of a corroded manhole before preparation. And here, after applying the device. We tested the surface stability by pull-out tests, and the results were quite assuring. The value of tensile strength was comparable to new concrete. Without a good surface preparation, the consequences are devastating, especially for coating systems. The water pressure detaches the coating from the manhole, and once the blister is big enough, the coating either collapses or cracks. The principles of failure can be described as a consequence of instability between the pressurized area of the blister and the holding forces at the circumference of the blister. Given a critical diameter of the blister, either the coating cracks or it detaches. If the blister detaches, then the diameter of the blister will increase even further until total instability of the system. So you can see from these examples, manhole rehabilitation is a very interesting subject, a lot of money to be invested by a variety of materials and methods, and there is a lot of knowledge needed for good quality. Concerning quality issues, IKT will start further activities in 2016. We want to develop standard terms of contract for manhole rehabilitation, also including quality assurance and quality control measures. We want to expand our European network of utilities and municipalities on a more international level, and we are going to start further educational programs on manhole rehabilitation. From pressure pipes and manholes, we now get to some more conventional issues. Repair of house connections and sewer lining testing. Nevertheless, these topics are still very important for quality research and testing. The topic of house connections is a very dominant issue here in Germany. By law, most private house owners had been obliged to check and rehabilitate their private sewer system. Moreover, the responsibility for checking the state of house connection lines in public space has been expanded to the municipalities. Against this background, we have just completed a test on repair techniques for house connection joints in the main sewer. And just now we have started a large research project and comparative product test on the rehabilitation methods for house connection lines. What we are looking at is the question, how can we repair severe damages? We call them Class A damages, in that very pipeline that connects the main sewer to the house. The budget is more than 1 million euros, and this includes a study on renovation methods, one-to-one scale tests, as well as in situ tests, and of course, the exchange of experience between network operators. The test has been open to international participants, so if you as a municipality want to take part, you are more than welcome. Just let us know. On this slide, you get a first impression of the one-to-one scale test. We will set up 20 house connection lines in 2 layers, each with 10 lines to test the repair systems. The task will be to repair damages in the upper and lower layer of the system. We plan to test short liners, injection techniques, robotic systems, as well as metal sleeves. Flooding techniques have also been discussed, and they could be a very good option for an international partner project. Of course, we are not just looking on the house connections. We are also focused on the main sewer, especially with regard to sewer lining testers. We all know a large part of the pipe production is realized on site, so quality control is crucial, because most of the possible defects can't be removed during the production process. Once the liner is produced on site, the result is delivered to the client. By this, the goal must be to produce 100% quality. Then the question is, who has to check the quality? Well, by nature, the incentive for quality checks is quite low for the producers themselves. If a defect is found, it is difficult to remove it, so better don't find one. So in the end, the municipality or utility, the one who pays, must also check the quality of the product. We have been doing these checks for the municipalities for years, and comparing the results over the years, it became quite clear. Regular quality checks by the customer lead to an increase of quality and reliability. And that's true for all kinds of material properties, be it wall thickness, elastic modulus, creep behavior, or water tightness. However, there are still 2 more major topics we are discussing and where we are preparing new activities. The first is the question of warranty. Some loading conditions may influence the long-term quality, and these can't be checked after installation. A good example is the resistance against sewer cleaning. On the left, we can see a perfect liner that has been accepted after installation. During warranty inspection after 5 years, large defects were found. Most of the defects seem to be a consequence of intensive sewer cleaning, which hadn't and couldn't be tested after installation. In our new projects, we are going to monitor liner quality for all participants. That is, we are going to check the quality after installation, but we are also going to analyze the quality at the end of warranty, and we will derive appropriate contract requirements. The second major topic focuses on the pipe soil system behavior. A prerequisite for the stability of a liner is that the pipe soil system is stable, or at least that we know how structurally stable it is, for example by classifying the state of the host pipe according to public guidelines, like you can see here according to a German classification. But how can we know or even measure the stability of the system? Well, by using, for example, the so-called MAC system, MAC system. Together with the Paris Waterworks, Eau de Paris, and our partner Olivier Thiepaut from Paris, we are currently developing new versions of the established French MAC technique. The idea is to push the pipe from inside with a pressure jack and to measure the deformation. Then by back calculation you get reliable information on the pipe and the soil stiffness, all without any destruction of the pipe or its parts. The measurement can help to identify a suitable rehabilitation technique, for example injection to improve the soil and lining to improve the pipe. But the measurement can also help to verify the success of any rehabilitation. We can compare the results before and after rehabilitation, so success can truly be quantified. Well, from trenchless, let's get to open cut now. Some may think that's not innovative, but it is. As we have discussed before, the pipe soil system is crucial. Using innovative soils is the key to innovation in open cut methods today. Those liquid soils consist of conventional soil, cement, bentonite, and water. On these pictures we can see the working principle. A liquid soil mixture is filled via a chute into the trench. The soil flows around the pipe and the whole pipeline has to be secured against uplift and buoyancy. After some hours, the soil congeals, hardens, and becomes a solid mass. The goal is to get a material that is solid but can still be dug up by using a shovel. Our laboratory research has shown that the bedding behavior is truly great. Stresses and strains in the pipe can be much lower than in conventional open-cut construction. The most difficult part is the installation process. And that is exactly what we are looking at in our next project. We want to take a closer look into the different products, the installation process, and the quality criteria. The goal is to develop standard terms of contract so that the material and the installation can be contracted in a reliable way. Let's turn now to some operational issues: sewer cleaning and flow control. Sewer cleaning is a topic that IKT has been analyzing for more than 15 years. The cleaning vehicles are big. However, the insight into the process had been small. Sewer cleaning always occurs in a hidden, dark space and nobody really knew much about its effectiveness and efficiency. So we started by looking at vehicles, water pressure, nozzles, and the whole process. We did it also in laboratory tests on small scale and one-to-one scale. And we developed a demand-oriented approach for sewer cleaning. That means only to clean the pipes where it really needs cleaning. We did all this because the topic is huge. Cleaning costs amount to about 500 euros per year and per meter. So a 200-kilometer network requires cleaning costs of about 1 million euros a year. And optimizing sewer cleaning means to improve all kinds of things: the qualification of staff, the pumps and nozzles, the technical process of cleaning, and, of course, the resistance of pipe materials against sewer cleaning. As an outlook for the next years, I can say sewer cleaning will be a main topic of our curriculum for certified professionals for sewer operation and maintenance. This certification is a German program that we plan to expand also to other European countries. Most of our technical standards are European today, and maybe It is also an option for international education. We've also developed a German handbook for sewer cleaning. It's in revision now. Maybe an English version can also be helpful in the future. A very sensitive device in our sewer systems are flow control devices. They control the flow and discharge at stormwater overflows in combined systems. In our research and testing, we've seen that operational conditions are of major importance for the performance of these devices. Now, we are going to test the available products in a comparative test for network operators. We are also going to qualify their staff to carry out in situ calibrations of these devices by themselves. So that was my overview about our current projects and our goals for the next years. If you want to join us in our projects, you are more than welcome. Feel free to contact us at any time with any idea for cooperation or joint activities. This is Thomas and me. We are curious about your feedback. And if you like, we can have an individual follow-up meeting later. Just let us know. Moreover, for your company as a whole, there is another option. Your company can become a member of IKT. As I mentioned in the beginning, IKT's shareholders are two associations. One of network operators, that is municipalities, utilities and water associations. And the second one, the association of the industry. That is, of all other players in the market. If you decide how to become a member, please take a look at our international website www.ikt-online.org. You will find a list of our current members as well as info packages on benefits and member fees. I am looking forward to welcoming you as a member of IKT. Okay, so I think we can close this webinar session now. Thank you everybody for attending. It was a pleasure to have you with us. I hope you have learned something new about IKT and our projects. And please remind for any further discussion, we can set up an individual meeting. Just let us know your ideas and we will follow up. So for guests from US, Canada and Brazil, all the best for starting your day. And for Europe, it's late in the afternoon, so all the best for your way home. And for our friends in India and Singapore, I was really proud and impressed about your ambition to stay up late at night, midnight in Singapore, just for this webinar. Special thanks to you for